We'll see about, who do we play next? Colorado? Okay. So last week when we were talking about the Ricardian model, we saw that David Ricardo about 200 years ago basically hypothesized that international trade could be explained in terms of differences in labor productivity. About 100 years ago, Eli Heckscher and Bertram Olin decided that they had noticed that there was a lot of international trade that was taking place, particularly in continental Europe, between countries where labor productivity was not that much different from one another. So they knew that there had to be reasons other than just differences in labor productivity that could account for international trade and the gains from international trade taking place. What Heckscher and Olin actually investigated was that it was the amount of resources that one country had relative to other countries. So they actually made the assumption that production technologies or labor productivity would be exactly the same between countries, that the only differences would be in countries' resource endowments, how much of a particular resource that they had relative to other countries. So today what we want to do is start the initial building of the Heckscher-Olin model to look at this hypothesis. So as we did last week, we'll start with just looking at an economy and autarky and how this assumption about different resources can affect our production possibilities curve. And then on Thursday, we'll look at what happens under these circumstances when we open it up for international trade. Just keep our assumptions in mind. We're still going to only have our two countries. So again, this is just to keep the analysis on the simple side. All of this would generalize to more countries if we wanted. We're also just going to have two goods. In this case, we're going to call them machinery and clothing, just to get away from wine. And again, we could generalize this to many more goods if we wanted to, so this assumption just is to keep the analysis on the simple side. We're now going to assume, however, that there are two factors of production. So remember, in the Ricardian model, there was only labor as a factor of production. So now we'll assume that there are two, that we still have labor, obviously we need workers, but in addition we also have capital. So we've got machines and other types of capital equipment or capital goods that are necessary for producing goods and services with. Factor mobility will stay the same. Factors can move costlessly and freely within a country, or between industries, but they're completely immobile between countries. So again, exactly the same way that we set up the Ricardian model. Now here are two new assumptions that we're going to use with a couple of endowment or definitions as well. So we're going to talk about factor endowments. And what we're going to assume here is that the U.S. is relatively capital abundant and China is relatively labor abundant. What we mean specifically about that is that if we look at the capital to labor ratio in the U.S., that it would be greater than the capital to labor ratio in China. Okay. And that with China being relatively labor abundant, its labor to capital ratio, the inverse of what we had just above, will be greater than the U.S.'s labor to capital ratio. So notice when we talk about factor endowments or factor abundance, we're always making comparisons across countries, So factor endowments or factor abundance is what we're looking at here. Also notice that in a two-country, two-resource model, as we have set up here, if the U.S. is capital abundant, then by definition, China has to be labor abundant. Okay? Now, once we go to more than two factors or more than two countries, that's not necessarily the case, but at least in a two-country, two-resource model, if one country is capital abundant, the other will be labor abundant. Okay, so that's factor endowments. We also want to think about what we call factor intensities. So here we're talking about industries having intensities. So here we're going to say machinery is capital intensive. So what we mean by that is that the capital to labor ratio in machinery will be greater than the capital to labor ratio in cloth or clothing. That'll be true for the U.S. It will also be true for China. Whoops. So the capital to labor ratios are simply higher in machinery than they are in clothing. Okay, in both countries. When we say that clothing is labor intensive, again, we're simply saying that the labor to capital ratio is greater in clothing than it is in machinery. And again, that will be for both countries. So notice that when we talk about intensity, factor intensities, we're making comparisons across industries within a country. But the across industries is still valid for both countries. So notice, factor endowment or factor abundance is making a comparison between countries, where factor intensities is talking about making a comparison between industries within the country. And hopefully this particular notion makes sense, that some things require a much larger capital to labor ratio to make than other types of products. Now the question that we want to ask ourselves here is to recognize that when we have two factors of production, as producers we have some ability to decide what ratio of capital to labor we want to use. A lot of capital and not very many workers, or a lot of workers and not very much capital. So we have substitution possibilities within our factor mix. Notice in the Ricardian model we didn't have that. We only had one factor of production, so we had to use labor. And notice also that labor, we had unit labor requirements, what was absolutely required to produce a particular unit of output. That's no longer the case because, again, we've got this factor substitution. We could use a lot of capital and not very much land to produce one unit of output, or we could use very little capital and a lot of labor, I said land, didn't I? Labor, to produce a certain amount of output. So this is what we think of as factor substitution. And factor substitution plays a key role in the Heckscher-Olin model. So at this point, though, what we want to ask ourselves is, what is the relationship between relative factor prices and relative factor intensities? Bless you. In other words, how do we decide what mix of inputs to actually use in our production process? And obviously, it will depend, in part, upon what the cost of those factors are. If capital is very expensive, chances are we're not going to use as much, and we'll need to use more labor. If labor is very expensive, then we'll try to economize on the use of labor by using more capital. So that's the factor substitution that we want to think about. So in order to actually set this up, though, we want to think about isoquant curves, or isoquant lines. Now, an isoquant, iso just means equal, and quant means quantity. So what an isoquant does is it shows us the various combinations of capital and labor that would produce the same given level of output, whatever that level might be. It might be 1 unit, it might be 1,000 units, it doesn't matter. All we're looking at is how much labor and capital is actually going to be used. So if we were to put capital on the vertical axis and labor on the horizontal axis, an isoquant might look something like that. Let's call this IQ naught for an isoquant level naught. So this would be some particular level of output, and this would give us the various combinations of capital and labor that we would need in order to generate this level of output. So if, for instance, this were 1,000 units, we could see that we could use L naught, lots of labor, not much capital, K naught, or we could use very little labor and a lot more capital. Both of those combinations, L naught, K naught, as well as L1, K1, will generate the same level of output, 1,000 units. So that's all we mean by an isoquant. Now, if we change the level of output, if we wanted this to be 2,000, we'd just be looking at an isoquant that would be higher up, further away from the origin. So you want to think about a whole family of isoquants that are sitting out there, each at a different level of output. Now, where we pick along this isoquant to produce will depend upon the relative price of capital and labor. The relative price of capital and labor. What we know is that in competitive markets and for efficient economies, what we would like to do at any level of output is to minimize the cost of production. Right? So whatever your output is, if you want to make a profit, you want to minimize your cost of production. So we can minimize our costs, recognizing that our cost consists of two components. The amount of labor that we have times the wage rate, plus the amount of capital that we're using times the rental rate. So this then gives us our total costs, and that's what we want to minimize. Now for now, we're going to assume that the wage rate and the rental rate are fixed. So for any given wage and rental rate, we can see what the amount of labor and capital that we're using. Now we want to minimize that cost, so we can figure out how we actually do that. And the way that we do that is we take this minimization curve, and we now create not an isoquant, but rather an isocost curve, or an isocost line. So an isocost line just tells us what the various combinations of labor and capital are that generate the same cost for given levels of wages and rents. So here we've got our constant cost. Again, you can see that we've got labor, wage rates, capital, and the rental rate. So again, for any given level of cost, again, this might be 1,000, it might be 2, might be 500. So we could set this up so it is anything that any level of cost that we want to actually try to minimize. So we can take our isocost line and just rewrite it, solving for K. And so we've got our cost divided by the rental rate minus the wage rate divided by the rental rate times the amount of labor that we have. So this particular line, again, shows us the trade-offs that we can make in terms of capital and labor to maintain the same fixed cost, the same fixed cost. Remember, this is a cost curve, not a quant curve. So this is how much it's costing us, not how much we're actually producing. The key here to notice, though, is if we're going to use more labor, given this minus sign on the relative returns, we have to use less capital if we're going to keep the cost the same. Again, we've got that trade-off. You may remember that from our production possibilities frontier, where we had a trade-off. So this then gives us the slope of our isocost curve. The relative, in this case, the relative wage. So again, if we had capital on the capital on the vertical axis and labor on the horizontal axis, our isocost curve, if we have given wage rates and rental rates, might look something like that. Okay? So this is an isocost curve with a slope of minus the wage rate over the rental rate. Again, notice as we did with production possibilities frontiers, the numerator in the relative prices of our slope is the return associated with the variable that's on the horizontal axis. Okay? So now we've got a isocost curve. Now we can figure out exactly what are, given this isoquant, the way we would minimize the cost of production is to find the lowest isocost curve that is just tangent to that isoquant. So that will be at point A. So that then gives us the minimum cost that we can find to produce this level of output at this wage rate and this rental rate, or in fact this relative wage rate. And then that tells us to produce this level of output, we want to use this level of labor and that amount of capital. Okay. Probably give those knots there just to set that up. Okay. Now all of this is fairly standard, but the way in which it comes into the Heckscher-Ohlin model is what happens to our initial levels of capital and labor that we're using if the relative wage rate changes. So let's just suppose that the wage rate increases and the rental rate is constant. Okay. So notice that in that case, the relative wage rate increases. So how do we show that in this diagram? The slope of the isocost cost curve has become steeper, right? You're increasing the numerator, so this line becomes steeper. We still want to minimize the cost of production for this isoquant. So we're not going to move to a different isoquant. We still have this level of output. What we want to find now is how do we minimize the cost of producing this level of output at a higher relative wage? And of course, we still just want to find the tangency of our new isocost curve. Let's call this wages rise to W1. Okay. So we now have a steeper isocost curve. We can see to minimize our cost, we're now going to be at point B. Since labor has gotten more expensive, we're going to use less of it. And in a relative sense, capital has become less expensive, so we're going to use more of it. So notice that as the relative returns to the factors of production change, we're also going to change our mix of factors that we're actually using. So this increase then in the relative wage also implies an increase in the capital to labor ratio. Yes?
Yeah, so since the rental rate is constant, why does the amount of capital you use increase?
You mean why don't we rotate it off the axis? Remember, what we're trying to find is what is the minimum cost for producing this level of output. So we're not actually, I mean, we could rotate this curve down using that same amount, but notice we wouldn't be producing this level of output. So we would rotate it down, and then we would have to shift it out, because at that cost level, we couldn't produce that output. So we have to move back out to this isoquant. Yes? I'm sorry? Well, we have higher wages, and will it cost more? It's hard to know, right? Labor's more expensive, but we're using less of it. We're using more capital at the same price, so it would depend upon some elasticities in here that at this point we don't have any independent information on, although it probably would be. It probably would be. Now, this is the key relationship. Notice, as the relative wage rose, the capital to labor ratio also increased. So to generalize that statement, what we would say is, as the relative return to a factor of production increased, the relative factor intensity of the other factor, or the intensity of usage of the other factor of production, would also increase. Okay? So again, wages go up, we use more capital. Okay, so now then we can think about a new diagram where on the vertical axis we have the relative wage rate. Again, notice the wage rate divided by the rental rate on capital. And on the horizontal axis we've got the capital to labor ratio. Now again, it's important in looking at this diagram to realize what's in the numerator over here on our factor returns, the wage rate, ends up being the return to the factor that's in the denominator over here. So this is the capital to labor ratio, but that's the relative wage rate. Okay, so it's kind of important to keep that in mind, otherwise you'll get your diagram all mixed up. Okay, so with this, one of the things that we know is that we should have a positive relationship here, right? What we just saw was that as the relative wage rises, the factor intensity of the other factor, or the intensity of the other factor of production, will also increase. So as the relative wage increases, the capital to labor ratio will also increase. Now remember, we had two industries, right? So let me call this the CC curve for the cloth industry. But we also had the machinery industry. And in the machinery industry, this general relationship is still going to hold. So let me draw this out here. Now again, notice it's upward sloping. So as the relative wage rises, the capital to labor ratio will also increase. Two things to notice. One is I drew the machinery curve further to the right than the clothing curve. Why did I do that? And you know that because? Okay, so it lies to the right because machinery is capital intensive. So the machinery industry is always going to be using a higher level of capital to labor than will the clothing industry at every wage to rental rate ratio. Okay? So that's why it's further to the right. Now I tried to draw it, I don't know, I can't get back far enough to actually see, so that it actually also had a different slope. It may or may not, but I tried to draw it so that it at least looked like it had a different slope. And in fact, I drew it, tried to draw it, maybe I should have exaggerated, so it had a flatter slope. So what would that suggest, or what would these different slopes suggest? Mm-hmm. Okay, but why would the slope be different? Why would the slope